So hello everyone. In this video, I'll show an example and show you how the training phase of naive Bayes actually works using that example. Okay, so we have already derived the naive Bayes algorithm, right? So what we need to find out is okay. Let's see the data set first. So this is the data set. So there is data from D1 to D14. That means 14 days data is present. And these are the four features: outlook, temperature, humidity, and windy. Depending on these four features, we are simply saying the class as yes or no, whether I should play tennis or not, given some weather, right? Now, given a new weather on outlook, temperature, humidity, and windy, I should predict whether I should play tennis or not. That is our problem. This is the example. Okay, this is a very famous example which is used worldwide. You may have come across this, and I'm using this for simplicity. Okay, so for this example, what we need to find in the prediction phase, we need to find, given some query value x, let's say the query xq, for example, is like this. Say the first one is outlook, right? Let's say the outlook is sunny on a given day. Let's say sunny. Then let's say the temperature is hot, the humidity is high, and the windy is true. If this is xq, then what should be my prediction, whether I should play tennis or not, right? Now, in order to do that prediction, we have to find two things. One is, since it is binary classification problem, so we need to find probability of yes given the particular xq given this data point, and we have to find out probability of no given this query point, given the same query point. Which of the probabilities is greater? Say the probability of yes is greater than probability of no, then I will say I should play tennis. I will predict it as yes, okay, or otherwise. Now, from the derivation of naive Bayes, we have already got this, right? Probability of C given X, probability of the class given the query point, is equal to probability of C given F1, F2, F3, F4. Just I'm expanding X. X here is F1, F2, F3, F4. What is this F1, F2, F3, F4? This is F1, this is F2. These are the features, right? F3 and F4. This is X, right? And this is Y. Now, naive Bayes says that this is proportional to probability of F1 given C multiplied by F2 given C multiplied by F3 given C multiplied by F4 given C multiplied by probability of the class. Okay, so what actually we need to find out is probability of yes given X equals to this probability of F1 given C multiplied by probability of F2 given C multiplied by probability of F3 given C multiplied by probability of F4 given C, 4 given C multiplied by probability of, what is probability of C? Here in this case it is probability of yes, since I am finding out for yes. Okay, same goes for probability of no given X. So it will be same, everything will be same, just here it will be probability of no. This is the real scenario. This is what you need to do really, actually. Okay, from the notations may be confusing, but this is what you need to do finally. Okay, so what is probability of yes and probability of no? You can get it from the dataset itself. See how many yeses are present. Here you will see 9 yeses are present out of how many data points? 14 data points. So the probability of yes is 9 by 14, and probability of no is obviously 1 minus that, so 5 by 14. Okay, so we got these two values. So we have this. So what we need to find is these values. We need to find these four values, right? These four values will be same, right? It will be same, isn't it? Probability of F1 given C will be used here. It will be used here also, same. So we need to find these four values. because we have already these two values. So with these two values, the probability of yes and probability of no given x will be changing. Okay, so this is what we need to find out. Now let's go to the training phase. So in the training phase, what we need to do is we need to find those probabilities. Which probabilities? These probabilities. Probability of f1 given c, probability of f2 given c. These probabilities we need to find out, right? So that is what is found out in the training phase of naive-Bayes algorithm. Okay, so how it is found out? See, I have created a table here. So for outlook, this is for f1, right? I'll write here f1. For f1, this is the table. So what is it saying? It is saying for outlook. So outlook can have three values: sunny, overcast, and rainy. Now this column is for frequency, that is probability of yes and probability of no, how many times they are occurring. So you can see 2, 4, 3. I'll just write it here: 2, 4, 3, and here 302. 302. Okay, what are these values? So basically sunny and yes is occurring 2 times. You can see it. Sunny, how many sunnies are present? 1, 2, 3, 4, 5. 5 sunnies are present. Out of them, how many are actually yes? See it here. This sunny is no, this sunny is no, this sunny is no, this sunny has yes. 1 yes, this sunny has yes. So 2 sunnies has yes. That is what I have written here. This is play yes and this is sunny. So corresponding element will be 2. Sunny, no. How many? 3. Okay, you can check the data set. So totally 5 sunnies were present in the entire data set. Out of that, out of those 5 sunnies, 3 sunnies are corresponding to no. That is why I have written here 3. Same, in the same way, overcast, play yes is 4. See, overcast, I'll change the color. Overcast, 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 overcast. See, this overcast is yes, this overcast is yes, this overcast is yes, this overcast is yes. All the overcasts are yes. So I have written here overcast play equal to yes is 4 and play equals to no is 0, because there are no overcasts which has play equal to 0 or play equal to no. Okay, that is why 0. In this way I have filled out this table. Okay, now we can find out the probability very easily. How many points are present? Totally sunny points are 5 points. So this is basically 2 by 5 and this is 3 by 5. Play no, play no's probability is 3 by 5. Play yes probability is 2 by 5, because out of total 5 points, sorry, I think this is wrong. Just a second. See, actually this is probability of yes, right? Probability of yes. So how many yeses are present? 9 yeses are present in total. Out of that, only 2 are yes for sunny. So I'll have to write here 2 by 9. Okay, remember this. We are not doing from this. Here we have 5 sunny points, but that is not what my probability is. What probability am I finding? I am finding the probability for yes, not for sunny. I am finding out the probability for yes. So what is the total probability, total number of yeses? See, 4 plus 2 is 6 and 3 is 9. So totally 9 yeses are present. Out of them, only 2 are for sunny. That is why 2 by 9. Same goes for this. How many negative points are present? 3 plus 2, 5 points. Entire data set, 5 negative points are present. So out of the 5 negative points, 3 are sunny. So we'll write it like this. Same here, 4 by 9 and 0 by 5. This is 3 by 9, 2 by 5. Done. So we got some probabilities here. We got this. So this is for F1. In the same way, we'll have to find out for F2. I'll do it in this table. I'll just edit it. Okay. I'll just edit it. You remember the values? You do it in your copies, you will have the values, because we will be needing these values. I'm just deleting this and for saving my time. So let's say this is temperature. So what are the values? So hot, mild and cool. So hot, mild and cool. Okay, and this is F2 now. So what are the values? It will be 2, 4, 3. I'm just copying the values so that there is no mistake. You can check it. Okay, so this is 2 by 9, this is 2 by 5, this is 4 by 9, this is 2 by 5, this is 3 by 9, and this is 1 by 5. Okay, so this is how you will get the tables. So in the same way we'll be finding for F3 also. Okay, I'll just again edit it. You can write the values, pause the video and write the values and check it whether it is correct or wrong. Don't just believe me, you do it on your own. Okay, otherwise you will not be able to do it. So next is, I think, humidity. So let's do it for humidity. So what are the values? The values are high and normal. So this is for F3. And what are the values? Values are 3, 6, 4, 1. Okay, and so it is 3 by 9, 4 by 5. Okay, so this is what you will get, and you can pause the video and copy it. Write the next one. It's the same way. Okay, there is nothing magical here, no rocket science. So next one is, I think, windy. So windy can be true and false. So what are the values? This is basically F4. Okay, so 3, 6, 3, 2, 3, 6, 3, 2. So this is basically 3 by 9, 6 by 9, and 3 by 5, 2 by 5, if I am not wrong. Yeah, so we got all these values, we got these tables, right? Now once we have got these tables, next we can directly predict. Okay, I'll just go back here. Okay, I'll just write it again. So what we need to find out, given some query point, let's take a query point. Let's say the point is xq, which is, let's say, sunny. Okay, then it is cool, then humidity is high, and windy is true. What is the prediction for this? Okay, what we need to find out, probability of yes given xq, which is probability of f1 given yes multiplied by probability of f2 given yes multiplied by probability of f3 given yes multiplied by probability of f4 given yes multiplied by probability of yes. Just find this. Now tell me, what is probability of f1 given yes? What is f1? F1 here is sunny, right? Okay, I'll just write it. So this is basically probability of sunny given yes. This is basically probability of cool given yes. This is basically probability of hot, not hot, high humidity given yes. Probability of true given yes, wind is true, and probability of yes. Now find out the values. I made it easy for you. So what is the values? Look at the tables. Look at the first table. Probability of sunny given yes. Probability of sunny, look at the row. Probability of sunny and yes, it is 2 by 9. So just write here 2 by 9. This is what we have already stored in the training phase. Now this is the testing phase, remember. This is the testing phase. Testing phase or the prediction phase. We are given a new point and we are predicting now. Okay, using what we have stored in the training phase. Okay, so 2 by 9 multiplied by, what is probability of cool given yes? See in the temperature table. Cool given yes is 3 by 9, if I am not wrong. So 3 by 9 multiplied by probability of high given yes. See the humidity table. Probability of high given yes is 3 by 9 again. Multiplied by probability of wind equals to true given yes. Wind equals to true given yes is again 3 by 9. Yes. And multiplied by probability of yes. What is probability of yes? It is 9 by 14. So 9 by 14. If you find this value, it will be almost like 0.0053. 0.0053. Okay. In the same way, you need to find out probability of no given the same query point. It will be 2 by 9 multiplied by 3 by 9 multiplied by 3 by 9 multiplied by 3 by 9 multiplied by 5 by 14. That is the difference. Okay, because probability of no is 5 by 14. The result you will get is, oh sorry, I'm very sorry, this is not what it should be. Just a second. Okay, probability of no is different actually. Probability of f1 given no, right? This is probability of f1 given no multiplied by probability of, let's write it as s here, sunny given no, probability of cool given no multiplied by probability of high given no multiplied by probability of, I don't think this is overlapping with the picture of mine, true given no multiplied by probability of no. So this sunny given no, go to the sunny column, sunny row and no column. See the probability, it is 3 by 5. Okay, it is 3 by 5. Next, probability of cool given no is 1 by 5. Probability of high given no is 4 by 5. Probability of true given no is 3 by 5. And probability of no is 5 by 14. So if you find out the value, it will be almost 0.0205. 0.0205. Okay, which one is greater? This is greater, right? This probability of no given xq is greater. So we'll predict the class as no. We'll say will not play tennis. That's it. Will not play tennis. Okay, this is how the naive Bayes algorithm actually works, right? This is how it works. So we'll have to simply find out the probabilities of all the classes that are present in the dataset given the query point. Whichever has the highest value, we'll pick that as a prediction class. Thank you. See you in the next video.